Hello to everybody, my name is Roberto Iona and I wish to welcome all of you. I want to start with a simple question. You have 1000 euros and they rise by 3% per month. How many euros will you have after 4 years? Yeah, I know, it's not so easy, but you will be easily able to answer using the exponential function, but we will see that later. Now I'm gonna tell you some basic rules and information about this kind of mathematical function, and then we will see some application in the real life. Let's start. So, I would start telling us this kind of mathematical function is very similar to the others, with only one big difference. Now, the variable is the power rather than the base. So, an exponential function looks like something like that. For example, if we consider a simple constant like 2 as n, the function will figure 1 when x is equal to 0, 2 when x is equal to 1, and 4 when x is equal to 2. And we could do a lot of examples. On the other hand, if we consider n as a number included between 0 and 1, we will have a decreasing and specular function. For example, if we consider 0.5 as n, the function will figure 0.25 as x is equal to 2, and 0.125 is x is equal to 3, and so on. It's easy to see how fast does an exponential function grows. Let's just think as a simple number, a little number like 2, with an exponential like 10 reaches 1024. Looking at the graph, it's possible to realize how it is low before the 0, almost becoming a second x-axis, but never touching it, and how it's fast after the 0. Let's see some rules. For example, with n greater than 0, we will have a always positive function, and n must be different from 0 and 1. We are now gonna solve an easy equation. 3 to the x power is equal to 81. We just need to keep a common base in both sides, the smaller number, that in this case is 3. So, now we transform 81 in 3 to the 4th power. At this point, we write x equals to 4, because the two numbers will be equals only if the exponents are equals. If we couldn't transform 81, we should use the logarithmic form. Now I want to show you how exponential functions are often used in science. For example, this is the formula to calculate the amount of a radioactive element's atoms, or to date it by this datum. N stands for the number of atoms, and 0 represents the initial number of atoms. T is the time, that usually is what we are looking for, and X represents how much time this element needs to halve. For instance, uranium's decay process lasts 4.5 billion years. Now, to conclude, I'll show you the answer to the first little riddle. This is a very powerful formula. It allows you to know how much money you will have after a certain period, considering an interest rate. F stands for the final amount, I for the initial one, R represents the interest rate, and N is the number of compoundings a year. For example, it is 1 if it is a year, 12 if we consider every month, 365 if we consider the days, and T is the total number of years. At the beginning of the video, I gave you 1000 imaginary euros, and I said that the interest rate was about 3%. So, I is equal to 1000, R is 0.03, N is 12 because money rises every month, and T is 4 because we consider 4 years. The result of this equation gives us the final amount of the money. Powerful, isn't it?
Now I want to tell you a legend. The story tells us that long ago, the great Sultan of India loved to play games. As he started to get bored of the games that were present at the time, he asked a wise man who lived in his kingdom to come up with a new game. This, according to the legend, is how the game of chess was invented. The Sultan was very pleased with the wise man who had invented the game, and in return he offered the wise man a reward of his own choosing. To the Sultan's surprise, the wise man did not ask for any gold. Instead, he only had one request. He asked just for a few grains of rice. In the following manner, the Sultan was to put a single grain of rice on the first chess square. 2 grains on the second square, 4 on the third square, and carry on doubling this number on every consequent square to fill up all 64 squares of the chessboard. This seemed to the ruler to be a modest request, so he called for his servants to bring the rice. Did the Sultan manage to fulfill the wise man's request? Obviously not. Let's just think that the total number would be this: 1-8-446-774-073-709-551-615. And no, it's not my phone number. Just to understand, this amount of grains would occupy almost all the Switzerland.
And for today, that's all. Thank you for watching.